Hello, I'm Mrs. Simpson. Those of you who know me, I'm here by special request to do a lesson on probability trees today, but I'll be doing other lessons on other topics in maths and in science, and if you send me a message then I'll see what I can find out to help you with any questions that you've got. I can see if I can prepare a lesson for within reason. I'll do my best. Today I'm doing probability trees. Two things you're going to have to remember are the word and the word or, because they're our probabilities. Today all you're going to need is a calculator, a pen or pencil to write with, and some paper to write on. So press pause, go and get yourself organised, maybe grab a cuppa and come back for the lesson. Today's title, Probability Trees, is what we're going to be looking at, making a tree so that you can see the different probabilities as they emerge. So we'll be looking today at knowing the word and means times and the word or means plus. They're the only two key things that you need to remember for this lesson so that we can work out the various probabilities. I'm going to work in fractions. Those of you who know me know that I love fractions, prefer them over decimals sometimes myself, but feel free, if you prefer to work in decimals, you can do that as well. I don't mind, because they're the same thing. The question I'm looking at today is how to work out probability trees with two separate outcomes. So the first one doesn't have any impact on the second one. So we're going to do two things. We're going to throw a coin, you can get heads or tails, and we're going to roll a dice. So first job, we have our start point and we throw that coin. Two possible outcomes: we could get heads or we could get tails. So this is how you set it up. Please leave a lot of room for a tree diagram, because otherwise they get really complicated and you have to start all over again. They're a nightmare. So make sure you space them out. On each branch of the tree, that's where we write the probability. So the chance of getting heads on a coin is a half, and the chance of getting tails on the coin also a half. If we get heads on the coin and our next job is to roll that dice, the dice we could get a 1, a 2, 3, a 4, or a 5, or a 6. They're all the possible outcomes on the dice. The chance of getting a 1 is 1 out of 6. Chance of getting a 2, also 1 out of 6. Same for a 3, 1 out of 6. 4 and 5 and 6, they're all 1 out of 6 chance. But what if we got a tails on that first go? Well, if we did, we get a tails, then we throw the dice. On the dice, we could get, a 1, or a 2, or a 3, a 4, a 5, or a 6. Now the chance of getting a 1 is still 1 out of 6, because it doesn't make any difference whether we got a tails or a head in the first throw. Same for the 2 and the 3 and the 4. They're all the same. So fill in all the branches of your tree. You're starting to see now why you need a fair bit of space so we can actually read your probabilities as you write them on there. Now we're going to list out all the possible outcomes. At the end of each branch, heads and a 1. That's what we could have got. Heads or a 2 is the other thing we could have got. Or a heads and a 3. A heads and a 4. A heads and a 5. Heads and a 6. Notice I'm using the word and. I could have got a tails and a 1, or tails and 2, or tails and 3. Again, the words and or keep coming up. Tails and 4, tails and 5, tails and 6. So now we've listed, this is our sample space. That's what they call it, the sample space of all possible outcomes. There are, in fact, 12 of them. So the chances of getting heads and a 1, well, that only occurs once out of 12. So it is, in fact, 1/12 chance. Look how they do it using probability. Heads and 1. Probability of heads is a half, and times. Chance of a 1 is a 1/6. What's a half times a 1/6? Oh my goodness, it's a 1/12. So if we'd done it without the whole tree, we could have just used the probabilities, a half and a 1/6, and we would have got the same answer. What's the probability of getting tails and a 3? Here it is here. Probability of tails is a half, and is times chance of a 3 is a 1/6. So it is also 1/12. In fact, all of these have the probability of 1/12. Now you might get asked a question such as, what's the probability of getting heads and an even number? So we look at each branch, heads and an even number. There's this one, heads 4 and heads 6. There are 3 chances out of 12. So the probability of heads and even is 3 out of 12, which is, we cancel down to 1/4. And we can see that from our tree diagram. How to do it using simple maths, we'd use heads and a 2, which is a half, and, which is times a 1/6. Heads and a 4 is also a half times a 1/6, and heads and a 1/6 is also a half times a 1/6. So we have a 1/12, a 1/12, and a 1/12. These are all or. We either have heads and 2, or heads and 4, or heads and 6. Remember, or is add. So 1/12 plus 1/12 plus 1/12 is still 3/12, which is cancels down to being a 1/4. So this is how we use a tree diagram. We put our numbers on each branch and it works out the probabilities. I'm going to give you one more example. This one is one that my Year 10s had that came up on the quiz I gave them, but it was similar to this. If we have 5 coloured marbles in a bag, say there are 2 reds and 3 blues, what is the probability of getting 2 the same colour? So what does that actually mean? So the probability of the same colour, we need to set it up using our probability tree. So on the first draw we could get a red or a blue. Now you have to write your probabilities on your branch. The probability of a red is 2 out of 5. So write that on there, 2 out of 5. Probability of a blue is 3 out of 5. So you can see they both add up to 5 out of 5. Now if we got a red the first time, what could we get the second time? Well, we could get a red and we could get a blue. If the question says that you replace the ball back into the bag, well, that means there's still 5 in there. So the probability of getting a red is 2 out of 5. If you didn't replace it and you'd had a red on that first draw out, well, now there's only 1 red left and 4 in the bag still. So this would be a 1/4, wouldn't it? But for our question here, we'll go with that we're replacing it. So if we got a red the first time and a blue on our second draw, well, there are 3 blues out of the 5 that are still in there. Let's say we got a blue on our first draw. We could get a red or we could get a blue on the second draw. So again, 2/5 and 3/5. So the probability of getting 2 the same, what does that mean? Well, it means either a red and a red, which is this one, or a blue and a blue, which is this branch. So the red and the red blue, we can either have 2/5 red and, which is times 2/5, which multiplies out to be 4 over 25. There's a 4 out of 25 chance of getting double red. What's a chance of getting double blue? Well, it's 3/5 and, which is times 3/5, which is 9 out of 25. Do you remember what the word or was? So we have a double red or a double blue. You're right, or is plus, isn't it? So the chance of getting 4/5, 4 out of 25, or plus 9 out of 25 would be 4 out of 25 plus 9 out of 25. We've already got a common denominator, so it's 13 out of 25, which is a lovely little fraction with a prime number on top, so we can't cancel it down. Yay, happy days. Now, one last question that everybody's been sending me questions about was this one in the quiz. We had a table with chances of rain, and it wanted to know the chance of getting 2 consecutive days of rain. So it had Friday, Saturday and Sunday. and that the chance of rain on each day was 60%. So this one they've given us as percentages, so we'll change it to, well, I would change it to fractions, but I'll do this one as a decimal for you. 0.6, 0.6, 0.6. 3 consecutive days. So we're going to set up a tree diagram that shows all possible combinations. Remember, this one's got 3. So we could, on Friday, it could rain or not rain. And we put the probabilities on the branch. Probability of rain, 0.6. So not rain, we have to use our mental arithmetic, has to be 0.4. If it rains on Friday, what could happen on Saturday? Well, it might rain, but it might not rain. Again, 0.6 and 0.4. We look at Saturday's chances. If it rains on Friday and it rains on Saturday, what could happen on Sunday? Rain or not rain? See how the tree gets quite big, so we have to be very careful to leave enough space. Rain or not rain, with 0.6 and 0.4 again, they told us in the table. 0.6, 0.4. So we do that. What if on Friday it didn't rain? The same thing happens. Saturday could rain or not rain, and Sunday, make sure you spread it out so that you don't get jumbled up. Now, 2 consecutive days means 2 days in a row with rain. So you look through your branches. Rain, rain, rain. That's 3 days in a row. So that does not satisfy our question. 2 days in a row. Rain, rain, not rain. Ooh, this one does. Rain, not rain, rain. They're not consecutive. It is 2 days of rain, but not consecutive. And this is 2 consecutive days not raining, so that doesn't answer our question. Look through our next branch. Not rain, rain, rain. There it is. And all the others, none of these do have 2 days in a row. So we're looking at either this branch or, see the word or, this branch here. So we've simply got to put those into our calculator. It's either this branch or this branch. So, as I'm running out of space, I'm going to get rid of my ticks. Rain, 0.6, and, so times by, 0.6 and 0.4. So the chance of this happening is 0.6 times 0.6 times 0.4, which is, you type it into your calculator, 0.144, 0.144. We type through this branch onto our calculator, 0.4 times 0.6, 0.6 and another 0.6, and we'll get again 0.144. The chance of this or that, either of those 2 branches, remember or is plus, so we simply add them together and we get 0.288 as your final answer. Now, I hope that helps you with the questions that I set you for homework, and I hope it helps you get your head around how probability works. I've made a little sheet that I'd like you to try to give you some practice on how to do probability tree diagrams without too much complication. So if there's things that are taken out, they are put back in so they don't bamboozle us. Please do like my YouTube video down the bottom and send me any messages if there are any questions that you'd like me, any topics you'd like me to do a little lesson on. Thanks very much for coming along. Happy homeschool!